Okay, so in today's lesson we're going to be looking at graphing linear equations in the form ax plus by equals c. Now, before we looked at linear equations in slope-intercept form. So they took the form y equals mx plus b. But now we're going to be looking at linear equations in a different form. The form we're going to be looking at today is called linear equations in standard form. And linear equations in standard form look like ax plus by equals c. So if we want to graph linear equations in standard form, so ax plus by equals c, we can do the following. So step 1. What we can do is find the y-intercept. So to find the y-intercept, what we can do is let x equal 0 and then solve our equation for y. So our y-intercept, remember, is where our line is going to cross the y-axis. Step 2. In step 2, what we're going to do is now find the x-intercept. So to do this, we let y equal 0, and then we're going to solve for x. So this is where it crosses the x-axis. Now in step 3, what you're going to do is plot the points that you've found for the x and y intercepts. And now that you have 2 points, you can draw a line through them. And then just extend your lines in both directions and add some arrows. And there you have it. A nice easy way to graph linear equations in standard form. Okay. Now let's look at an example. So let's say I have the equation 3x plus 2y equals 6, and I want to graph this. So, step 1. What we're going to do is we're just going to look at our table of values, and what I want to do is find the x-intercept and the y-intercept. So I need to know where x equals 0 and when y equals 0. So first, what we're going to do is find the y-intercept. So this occurs when x equals 0. So to find what y equals, we're going to plug our value for x back into our equation. So we get 3 times 0 plus 2y equals 6. And what's nice about this is when you take anything and times by 0, it just goes away. So then we're left with 2y equals 6. So now we have to isolate y all by itself. So we're going to divide both sides by 2. Now, on the left side, our two 2's divide each other out, so they essentially disappear, so we're left with y, and 6 divided by 2 gives us 3, so we're left with y equals 3. So when x equals 0, we get y equals 3, so that is where our y-intercept occurs. It's going to be at 3 along our y-axis. Now we're going to be doing the exact same thing, except now we're going to find our x-intercept, and this occurs when y equals 0. So, just like before, we're going to take our equation, and wherever you see a y, you're going to plug in 0. So we get 3x plus 2 times 0 equals 6. Now, just like before, 0 was such a nice number to use because it just makes things go away, especially when you're doing multiplication. So when we take 2 times 0, we get 0, and we're left with 3x equals 6. Now instead of y, we have x terms, so we need to isolate our x term all by itself. So we need to divide both sides by 3. And on the left side, our 3's divide each other out, so it just gives us 1, or just x, and then 3 goes into 6 2 times, so x equals 2. So our x-intercept occurs when x equals 2 and y equals 0. Then, now that you have your 2 points, you can draw your line, and easy peasy, just like that, we can graph equations in standard form. Especially when you're dealing with just your x-intercepts and y-intercepts, makes it really easy. Okay, let's try another example. Let's say I have 2x minus 4y equals 8, and I want to graph this. So, first step, we want to find our y-intercept, so we want to know when x equals 0. So let's plug it in. So we have 2 times 0 minus 4y equals 8. So 2 times 0 just goes away. So we're left with negative 4y equals 8. Now to get y all by itself, we want to divide both sides by negative 4. And then the negative 4's on the left side divide each other out. So we're left with y equals 8 over negative 4, or y equals negative 2. So our y-intercept is at 0 and negative 2. So we can plot this point on our graph. Now we want to find where our x-intercept is, or when y equals 0. So plug in y equals 0 into our equation. So we have 2x minus 4 times 0 equals 8. So 4 times 0 goes away. Gotta love 0 for that. So then we're just left with 2x equals 8. Now to isolate x all by itself, divide both sides by 2. So 2 divided by 2 on our left side becomes 1, so we're left with x. And on the right side we have 8 divided by 2, which equals 4. So x equals 4. So our x-intercept occurs when x equals 4 and y equals 0. Now, we have our 2 points, so all we need is 2 points to graph our line. So take your ruler, draw a straight line, add some arrows, and you have now graphed the equation 2x minus 4y equals 8. Now, this isn't the only way to graph linear equations in standard form. You can also do it this way. So step 1. So take your equation, write it out in standard form. So ax plus by equals c. Then what you're going to do in step 2 is you're going to use a little bit of algebra, and you're going to rearrange ax plus by equals c, or your equation in standard form, and you're going to make it look like y equals mx plus b, which is our equation in slope-intercept form. Now, personally, I like dealing in equations that are in slope-intercept form because I can see my y-intercept because I know my b constant, and given my slope, I can visualize what my line is going to look like and use that to graph it. So I can take my equation, ax plus by equals c, and using some algebra, I want to isolate my y term. So I want to isolate by by itself. So I need to minus ax from both sides. Now on the left side, if I take ax minus ax, that becomes 0, they just go away. So then what we're left with is by equals ax plus c. Now when I rearrange my equation, I want to put the x term first and then my constant. So I'm going to put the x term, so negative ax, and then my constant c. Alright, now we need to isolate the y on the by term. So I need to divide everything by b. So divide everything on the left side and everything on the right side by b. So on the left side, my b's divide each other out, so we're left with y. So we can rewrite this as y equals negative a over b times x plus c over b. Now, we have a lot of variables here, but as you can see, this is starting to look like our y equals mx plus b equation, or our linear equation in slope-intercept form. So instead of m, we've replaced that with negative a over b, so that's what m equals, and b equals c over b, so we are just giving it some new values, but our equation is the same as what we had before. Now, in step 3, we can use c over b to find your y-intercept, because that is essentially our b constant when we're using slope-intercept form. And then step 4, we're going to use your slope. So our slope in this case is negative a over b. So essentially that's our rise over our run. And you're going to use this to find your next point and then graph your line. So you can use this method, or you can use the method finding the x-intercept and y-intercept. Personally, it's all preference. It all just depends on how complicated your linear equation is. Alright, so let's look at an example using this new method. So I want to graph 6x minus 3y equals 9. So we can rewrite our equation. Now I want to isolate my y term, so I want to subtract 6x from both sides. So on the left side, 6x minus 6x is 0, it just goes away. So then we're left with negative 3y equals negative 6x plus 9. So remember how I said before, write your x term first and then add your constant afterwards, because we want this to look like our linear equation in slope-intercept form. Now, to isolate our y term, we're going to divide everything by negative 3. And on our left side, negative 3 divided by negative 3 is just 1. So we have 1y, or just y. And then we're left with y equals negative 6 over 3x plus 9 over negative 3. But whenever you're given fractions, remember, always reduce them if you can. So this can be reduced to y equals 2x minus 3. So this equation is much easier to read, at least I think, than looking at our equation in standard form. But it's just preference. This is just how I like to see it. You might feel differently, but now that I see this, we can easily find our y-intercept. So that occurs when y equals negative 3, because b equals negative 3, and we know our slope is 2. So we can also write this as a fraction as 2 over 1, so that is our rise over a run. So using these, we can easily graph our linear equation. So first, plot your point for your y-intercept at negative 3, and then you're going to go up 2 and to the right 1, plot your next point, and you could just continue this over and over and then graph your linear equation. Now, if you were to use the other method and find the x-intercept and y-intercept, you would also get the same result, just with just another way to show it. Okay, now what about if we have linear equations that are horizontal lines? So what do these look like? So let's look at the equation y equals 3. So what does it look like when we graph this? So first, what I'm going to do is give myself a table of values, and let's just plug in some values for x and see what happens and what do we get for y. So let's plug in 1, 2, and 3. Now, say if I plug in x equals 1, what happens? Okay, we got y equals 3. And I see no x's, so then y is just 3. What about when x is 2? Okay, so still no x's, so y is still 3. And same thing for when x is 3, y is still 3. So, doesn't matter what value for x that I pick, because the output, or my y value, is always going to be 3. Okay, so that's pretty easy. So, since we're dealing with linear equations in standard form, this can also be written as 0 times x plus y equals 3. So with our linear equation in standard form, a is 0, b is 1, and c equals 3. Alright, so now that we have our table of values, let's graph this. So make your graph, draw your x-axis, your y-axis, and we have our points 1, 3, 2, 3, and 3, 3, so graph those. So we only need 2 points to graph a line, but let's just keep it going. And there, we have our linear equation. So when y equals 3, that is what the graph is going to look like. It's going to be a horizontal line at y equals 3. Alright, now that we've looked at horizontal lines, what about linear equations for vertical lines? So let's look at the equation x equals 2. Okay, so instead of having y equal a constant number, we're going to look at x equals a constant number. So in this case, x equals 2. So make my table of values just like last time, except I'm going to plug in values for y and see what x equals. So let's use y equals 0, y equals 1, and y equals 2. So when y equals 0, there's no y, so then x is just 2. And since there's no y's anywhere, your answer is always going to be 2. So, just like before, doesn't matter what value you pick for y, the value for x will always be the same. In this case, it's always going to be 2 because our equation is x equals 2. And since we're dealing with linear equations in standard form, we can also write this as x plus 0 times y equals 2. So our constants in standard form are a equals 1, b equals 0, and c equals 2. So we got our table of values. Let's plot our line. So at 2, 0, 2, 1, and 2, 2, we have our 3 points. And we can use these to graph our line. So you could just draw a straight line through. But let's just extend some more dots. And now we have our nice vertical line. So when x equals 2, you'll have a vertical line that looks like this. So graphing linear equations in standard form is a little bit different than graphing linear equations in slope-intercept form, but as long as you follow the steps, you should have no problem. Okay, until next time.